Okay, so now we're talking about methods to make artificial magnet. So the question about you guys asking how to make electromagnets and how do electromagnets work. All right, so single touch method. A piece of iron can be magnetized by rubbing it with a magnet from one end to another as shown in the figure. So remember I told you that if I have a piece of, all right, so let's say I have a piece of iron. Okay, so this is a piece of iron, and what I do, I take a magnet, okay, and I rub it against this piece of iron in this particular direction. I start from this side, from the left to the right. Okay, I take a piece of iron. Let's say if this is a piece of iron and this is my magnet, and I take one end of the magnet and I rub it from the left hand side to the right hand side. My left hand, my right hand, okay, from the left hand side to the right hand side, and I have to take it, put it on the left hand side, drag it to the right hand side, lift it up, again touch the left hand side, drag it to the right hand side, lift it up, again touch it to the left hand side and drag it. So while going back, I have to lift up the magnet. I cannot touch it. Okay, so I always rub it in one particular direction. Okay, when you do that, that is when your iron piece will magnetize. If you don't do it in a particular direction, it will not magnetize properly. If you do it, if I just take it and I rub it like this, it's not going to work. I have to rub it in the same direction. Okay, why that happens? Does anybody know why that happens? Okay, so the reason that happens is because iron contains atoms. Okay, atoms contains electrons, and these electrons are small particles. Okay, and these electrons, they keep on spinning. So this is nothing but an electron. Okay, so these electrons spin. Okay, so they spin in random directions. Some spin in this direction, some spin in this direction. So they spin in different directions. But when I bring a magnet towards it, what happens? These electrons are negatively charged. Okay, so these electrons are negatively charged, so they will attract the north pole of the magnet, and they will all start spinning in one particular direction. So they'll all start spinning in this direction. So when they all start spinning in a particular direction, magnetic field is created. Okay, and because of this creation of magnetic field, this iron particle or this iron piece behaves as a temporary magnet. Now what happens if I take this magnet and I rub it just randomly
Can I say the reason of that?
Yes, please.
That time the electrons, some will go this side and some will go that side. That time this will not be together. That time this magnetic effect will not get into this iron piece.
Very good. Yes. So when I rub it randomly like this, not in a particular direction, then what happens? All these electron spins will again spin in random directions. It will not spin in the same direction. And if it doesn't spin in the same direction, then the magnetic property will not be induced. Okay. Good. All right. So yeah, Neha also remembers. Good job, Neha. All right. So
ma'am.
Yes.
I have a doubt. So you told us how we figure out a magnet. I mean, yes. which one is the north and which one is the south, the directions. So when it comes to a circle-shaped magnet, how do we figure out the circle-shaped magnet?
Oh, circle-shaped magnet. Okay, good question. In that case, what you would do is you take a magnet, you take a bar magnet, okay? You take a bar magnet and you bring the circle-shaped magnet close to the bar magnet. Okay, you know the north pole of the bar magnet and you know the south pole of the bar magnet. Now, whichever side attracts the north pole of whichever side of the circle magnet attracts the north pole of the bar magnet will be the south pole of the circle magnet.